Hello, this video is the next in the series on organic chemistry. We've been looking into crude oil, we've done the fractional distillation video, we've looked into some past exam questions on fractional distillation and crude oil. So now we're going to explore what are hydrocarbons, and we're also going to look into how do we name the basic hydrocarbons. So we'll start off with some alkanes. Now looking into hydrocarbons, so when you study hydrocarbons, you're studying organic chemistry. So organic chemistry is predominantly the study of carbon-containing compounds. So everything you study in organic chemistry will have carbon along with hydrogen. So if you have carbon and hydrogen only, then you say that compound is hydrocarbon. So if you've got alcohols contain carbon, hydrogen, and oxygen. Therefore, alcohol will not be a hydrocarbon. So it's quite a commonly asked question. What are hydrocarbons? You've got to use the word only. Now we know that there should be covalent bonds around carbon. So each carbon has got, we know carbon is 6, 12, so it's got 6 electrons in its last shell, so it's got 2, 4 electronic configuration. So around carbon, if I put 4 electrons like this, that means if it's bonding with hydrogen, it would bond in that way. You've got hydrogen, each hydrogen needs 1 more electron to become fully filled. So if you draw the dot and cross structure, you would get something like this, and around carbon, now in that circle, you've got 8 electrons. So each pair of electron is the bonding electron pair. So each bonding pair of electron is representing one single covalent bond. So when you show it as bonds, you would just say carbon. You would, instead of showing dot and cross, you would just show one single line indicating it is a single bond. So that around carbon you have single bonds. In this case, each carbon, because it's bonding with 4 hydrogen, you will show 4 single bonds. So it's quite important to remember around each carbon you'll have 4 lines. There are different ways to represent organic compounds. We're going to be looking into all these formulae that will come your way. So commonly we say molecular formula, and molecular formula, when you look at that formula, it tells you the exact number of atoms of each element. C2H6, by looking at that, I would know that this compound has 2 carbon atoms and 6 hydrogen atoms. So that's a molecular formula. Structural formula will only show the structure. So it's not going to show you the bonds, but it will just show the atoms carbon by carbon with the attached hydrogen. And if you've got functional groups, it will show that as well. So note over here, none of the bonds are being shown. It just shows the atoms by atom. If you want to show the bonds, that means you've got to display the formula. So now if these are the structural formula, if I have to show the displayed formula of ethane, I would have to open it up and show the bonds. So this is how a displayed formula is written. You open it up and then it becomes very clear what the bonding is inside that molecule. General formula is a representation of the whole family of compounds. So it's a formula where you would get the data in forms of N, CnH2n plus 2. So if N is equal to 1, I would say, if for alkane, that's the general formula, I would say C1H2 times 1 plus 2. Therefore, C, 2 plus 1 is 2, plus 2 is 4, so CH4. And I can go so on and so forth to figure out the whole series of alkanes. So when I do the whole series of alkanes, I would end up with lots of different carbon atoms. So I need to know, how do I name these alkanes? So we know that that's the general formula of alkanes. So if the number of carbon atom is 1, so I need to find out how many carbon atoms are in that compound. So it might be that I have to find the longest chain, and any side chain will be written as prefix. We won't be looking into a lot of prefixes in this video, but if you want to learn more about nomenclature or naming of compounds, please refer to the previous videos that I've made on that topic. So here, if for basic understanding, if you are doing GCSEs, then you would just need to know how to name simple alkanes. So simple alkanes, you would need to know, okay, if I've got one carbon, it's meth, two carbon, word root is eth, prop, but, and pent. And Jonah, I've got to thank Jonah for telling me this very interesting mnemonic to remember. So she said, this is how I remember: monkeys eat peanut butter. So, and I found this quite interesting way to remember: monkey, methane, ethane, propane, butane. So you could use that mnemonic to remember the word root. So if you've got one carbon atom, then you would call it meth. You would have it ending as ane because you would only see single bonds around it. So any alkane which has got 5 carbon atoms, you would say, okay, 5, that means it's a pent, and I would put ane at the end, so the name becomes pentane. So that's quite a simpler way of naming alkanes. And now that you've got methane, ethane, propane, butane, so if I just write down using CnH2n plus 2, if I write down the formula, so the first carbon is, with one carbon, the first alkane is CH4, the second alkane is C2H6, C3H8, C4H10. So when I name them, one carbon is meth, methane, 2 carbon eth, all single bond ane, 3 carbon prop, all single bond ane, 4 carbon but, all single bonds ane. So this whole series that I'm getting, that it belongs to a family of alkane because I'm using the same general formula. So what I'm getting here is called homologous series. So it's the same, belongs to the same family, and they would generally, when you look at the formula, the difference between the two formula would be CH2. So they differ by CH2. They will show the same chemical properties, but their physical properties would slightly differ. And they'll differ because their molecular mass and the number of electrons in them will be different. So that's the meaning of the term homologous series. Each family of hydrocarbons or organic compounds will be using a specific general formula, and anything derived from that specific general formula is your homologous series. Another way to represent, I've brought everything together here. I've also included ball and stick structure. So when you show displayed formula, it actually doesn't show the real structure of the compound. So when you look at the real structure, the bond angle between the carbon and hydrogen is not 90 degrees, but actually it's arranged in the form of a tetrahedron, and the bond angle is 109.5. So these are some common examples of different ways you can show alkanes. So skeletal formula is another way. So if I wanted to show CH3, it's just the formula would literally show the bonds. You don't show carbon, you don't show any hydrogen. So you look at the carbon here, you've got 2 carbons, so you would just show 2 carbons at the end of the line. So I've just put a dot there to show it to you. That's the skeletal formula. So if I had CH3, CH2, CH3, 3 carbons, so propane, so I would have to show 3 corners. So I can just show zigzag line. So that this is the skeletal formula. So skeletal formula would just be zigzag line 1, 2, 3. So 1, 2, 3, 4. So this one would be a compound containing 4 carbon atoms, which is butane. So far we've looked into some formulas here. So we've looked into molecular formula, structural formula. Molecular formula is the actual formula. Structural does not show you the bonds. Displayed will show you the bonds. General formula is the algebraic formula from which you can derive the molecular formula of the compound. Skeletal formula just shows you the bonds, so you would draw zigzag lines. And then we looked into naming of alkanes. So remember, monkeys eat peanut butter, so you write down the meth, eth, prop, butane, so but, and then you add ane to it. So the ane indicates that the compound only has single bonds. So we saw that each carbon should be surrounded by 4 bonds. So there are 4 covalent single bonds around each carbon. So I hope this video has been helpful, and in the next video we will be looking into the homologous series and how the homologous series change in their physical properties. So we'll be focusing on alkanes physical properties in the next video. So thank you for watching. Don't forget to like and subscribe to the channel. Thank you. All the best. Bye.